All right, so today we're going to take a refresher back to kind of Algebra 1, Algebra 2. Since we've been talking about parallel and perpendicular lines, we're going to tie that in with parallel and perpendicular lines on the coordinate plane. So this formula for slope should look very familiar. We have y2 minus y1 over x2 minus x1. You may have also heard of that as the change of y's over the change of x's. Or you may have heard it as rise over run. Because remember, on a graph, our x-axis is side to side, my y-axis is up and down. Okay? When we're talking parallel slopes have the exact same slope. Okay, exact same number, exact same sign. Perpendicular slopes have opposite reciprocals. What did that mean? That meant we flip it and change the sign. And that's how we get those lines to meet at 90 degrees. Okay? You had two different equations that we used. The most frequently used one is slope-intercept form. That was our y equals mx plus b. Remember from that one, our m represented slope, our b represented y-intercept. And then we also use point slope a little bit, which is y minus y1 equals m times x minus x1. And from that one, the m again was your slope, and then you were given a point as well, which would have been your x1, y1. All right, let's see, one other refresher was slope. I'm going to put that over here. If we have a 0 on the top for our slope, this is 0 slope or no slope. If we have a 0 on the bottom for slope, it's undefined. Okay, so you need to know those two terms for sure. Make sure you know that. All right, so when you're given 2 points, the first thing that I want you to do is label. Label, label, label. That will help you not make silly mistakes. So I'm going to look at number 1 with you. On number 1, we're going to label x1, y1, x2, y2. And then we're going to start plugging and chugging into our slope equation because we're just finding the slope. All right, so we have y2, which is 5, minus y1, which is negative 8, over x2, which is 12, minus x1, which is 4. We're going to bam, bam the minus, minus. 8 plus 5 would be 13, over 12 minus 4 would be 8. The next thing I want to do is, can I simplify that at all? 13 over 8. No, nothing goes into 13 and 8, so this would be fully simplified. Okay, make sure we don't change it to a decimal. We like fractions for slope. So parallel slope. Remember, parallel is the exact same slope, so it doesn't change at all. Perpendicular slope, we flip it and change the sign. Okay, I want you guys to try number 2. I'm going to highlight that for you. So you guys are doing number 2. Go ahead and pause the video and do that. All right, now let's talk about when it comes from an equation. So up at the top, this m represents our slope, right? But that m, y has to be solved for, or it has to be in point slope form. So when we're on number 4, we have y solved for. Y is completely alone, which is good. So I can go ahead and pull out my m. The m is always in front of the x value. It does not include the x. It's only the number in front of the x. Remember, whole numbers are always on top of a 1. That'll help you with the perpendicular slope. So for the parallel slope, it doesn't change at all, so it's negative 3. For the perpendicular slope, I can put this over a 1, so I'm going to flip it and change the sign so it's now positive. So there's your perpendicular slope. But what happens if it's not solved for y? If y isn't solved for, we have to solve for y. So if I look at number 5, I need to get y by itself, so I'm going to isolate my variable first. So what else is over there with the y? I have the minus 6. How do I move the minus 6 to the other side? Opposite of minus would be plus. So I'm going to plus 6 to both sides. I have 2y equals 3x plus 6. I have 2 times y, so I'm going to divide everything by 2. And y equals 3 halves x plus 3. Make sure you leave slope as a fraction, okay? So the number in front of x is our slope. So this guy's our slope. So my parallel slope would be the exact same. My perpendicular slope, I flip it and change the sign. Okay? You guys try number 6. All right, writing equations of lines. So for this one, you're either given y equals mx plus b, so point slope form, okay? Or slope intercept form. If you're given the slope and the intercept, use y equals mx plus b. If you're given a point and a slope, use point slope form, okay? So number 7. On number 7, it gives us slope, that's an m, and y-intercept, which is our b. So that one's nice because we can use y equals mx plus b. We can take our m, put it in for m, take our b, put it in for b. So I have y equals 8 over 5x plus negative 7 over 3, or you could just do minus 7 over 3. That's the same thing. Okay, so those aren't too bad. Now let's review point slope form. On number 8, it gives me my slope, which is m, and then it gives me a point, x1, y1. So I'm going to use point slope form. Remember, point slope form was y minus y1 equals m times x minus x1. So we have y minus 7 equals negative 2 times x minus 4. You should have a y and an x in each equation when you're making the lines. All right, so let's solve for y. I'm going to distribute that negative 2. So I have y minus 7 equals negative 2x plus 8. I'm going to add 7 to both sides. I'm running out of room here. So if I add 7, we get plus 15. Y is done, so there's your equation of your line. Okay, I want you guys to try number 9. Go ahead and pause and do that. Okay, so on number 10 is a little bit different. 10, it gives you 2 points. Well, what do we have to write an equation of a line? You have to have slope, and then you have to have a point. Well, it doesn't give me slope, so I'm going to have to find slope. So I'm going to label my points x1, y1, x2, y2, and then I'm going to find my slope first. So I have y2, 11, minus y1 is 7, over negative 3, that's x2, minus negative 5, which is x1. Minus minus, I'm going to bam it. So we have 4 over 2. 4 divided by 2 simplifies to 2. Okay, so my slope is 2. Now, it does not matter which point you use. I normally use the one with smaller numbers. For this one, it doesn't make much of a difference, so I'll just use my original x1, y1, which is negative 5 and 7. So I have my m, and I have my x1, y1. Now we can use point slope form. So we have y minus 7 equals 2 times x minus minus 5. I'm going to bam that, distribute my 2, and then add 7. So my equation of the line is 2x plus 17. There's your equation. Okay, now these next couple you need to pay attention to whether we want a parallel or perpendicular line. So on number 11, write an equation of a line parallel to y equals 5x plus 11 through 6, negative 2. So if it needs to be parallel to this equation here, I need to pull out my slope. My slope in that equation would be the guy in front of the x, which is 5, which means my parallel slope would also be 5. Now that I have my slope out of that equation, we're going to completely ignore it, and we're going to bring down the point that my new line needs to go through. So I'm using this information to come up with my equation. So here's my x1, y1. Now I can use point slope form just like we have been doing. So we have y minus negative 2 equals slope times x minus x1. Minus minus, we're going to bam, distribute that 5. And then subtract 2 from each side. So we have y equals 5x minus 32. There's your parallel equation. It would be the exact same equation if we had the same y-intercepts. That's why that y-intercept has to change. All right, let's try number 12. So number 12 wants a line perpendicular. Okay, so my slope from that equation is 1/3. That's the guy in front of the x. I want you guys to pause the video and tell me what the perpendicular slope would be. So yeah, the perpendicular slope, we flip it and change the sign. It would be -3. So now remember, we ignore the equation it gives us, we ignore the original slope, and then bring down the point that we need to go through. So our new slope we're using is -3, the point is 6, -2. So here's my x1, y1. Okay, we're going to plug it into our point slope form. So we have y minus y1 equals m times x minus x1. Again, we're going to bam bam that minus minus 2, distribute your -3. So we have y plus 2 equals -3x plus 18. Subtract 2 from each side, and my perpendicular line that goes through that point is y equals -3x plus 16. Okay, I'm going to skip number 13 and 14. We're going to come down to here. So let's look at 15, 16, and 17. This one we're telling if the two lines are parallel, perpendicular, or neither. So we want to compare our slopes, which means for each equation, y has to be completely alone. So if I look at number 15, y is alone on the first equation and the second equation. So on the first equation, my slope is 2. That's the guy in front of the x. On my second equation, my slope is 2. That's the guy in front of the x. Since they are exactly the same, what kind of slope would these two lines have? Parallel. Okay, let's try the next one. So number 16, y isn't solved for either equation. So I'm going to bring my equations down, and then I'm going to solve for y in each equation. Okay, so on the first one, what else is over there with y? I have a 2x, so I'm going to subtract 2x to get it to the other side. And then I'm going to divide each thing by -7. So I have y equals 2 over 7, negative over negative becomes a positive, minus 12 over 7. So there's one equation. Then I'm going to do the same thing to the other equation. I'm going to add 14x since it's a minus. So I have -4y equals 14x plus 11. Then I'm going to divide each thing by -4. So I have y equals, I can simplify 14 over -4. 2 goes into both of those. So 14 divided by 2 is 7. 4 divided by 2 is 2. And then we have 11 over 4. I can't simplify that one. So there's my second equation. Now what are my slopes in each of these? In the first one, the guy in front of the x is 2 over 7. In the second equation, the guy in front of the x is -7/2. So they're not parallel because they're not exactly the same. Did I flip them and change the sign? 2 over 7. If I flip that, I get 7 over 2, change the sign, and it's negative. So yes, I did flip it and change the sign. They're opposite reciprocals, so these would be perpendicular. There you go. Okay, so I want you guys to try 17. Go ahead and pause the video and try that one. Make sure y is solved for before you compare the slopes. Okay, the last thing we're going to look at is coming from a graph. So how do we tell if two lines on a graph are parallel, perpendicular, or neither? Now these pictures are really hard to count slope, so I'm actually going to find the slope with the equation. So number 18, I have this first line right here, and I need to find the slope of that. So I have my x1, y1, x2, y2, and it doesn't matter which way you label those. So I'm going to find the slope of the green line. y2 is 4 minus y1 is -2 over x2 is 0, x1 is -2. I need to bam bam. 4 plus 2 is 6, and then bam bam, 0 plus 2 is 2. I can simplify that. 6 divided by 2 is 3. There's that equation. Now for my other line, I'm going to make it orange. We need to find the slope. So I have x1, y1, x2, y2. So my y2 is -6, my y1 is 2, over my x2 is 2, my x1 is 4. -6 minus 2 would be -8, over 2 minus 4 is -2, and then -8 divided by -2 would be a +4. So here's the two slopes that we're comparing. Are they the same? No. Do I flip one and change the sign to get the other one? Nope. So this one would be neither. Okay, I want you guys to try number 19. So find the slope of each line, compare them, and tell me whether these are parallel, perpendicular, or neither.